Okay, we are going to talk a little bit about some of the stuff from Chapter 12 that we didn't get to on Friday, because as you know, Friday was kind of a weird day. One of the first things we had was a theorem that said that if F is a subfield of K, so we've got an extension of fields, then, thank you, Sophie, K is a vector space with coefficients from F. And we talked through a little bit about what a proof of that would look like by looking at the example. I think we looked at Q adjoin cube root of 11, and we also looked at Q adjoin I. Right? Both of these are Q vector spaces. One of the things we didn't get to was some notation that tells us about the dimension of one of these vector spaces over the base field. So if we write down, let's say Q adjoin cube root of 3 over Q, this had dimension 3, so this means the dimension of Q adjoin cube root of 11 as a vector space over Q, where the scalars come from Q. And you'll notice that this notation looks a lot like other notation that we've been talking about in class. So let's observe some stuff. If we take a peek at the degree, well, 3 is the degree, so let's undo that. It's the degree of x cubed minus 11, which is the minimum polynomial of the cube root of 11 over Q, and that turns out to be the dimension of the vector space Q adjoin cube root of 11 over Q. And it's not an accident. We'll see that these notations that we use are going to help us understand some things that are related, or some things that relate the dimension and the degree of the minimum polynomial. So that's it. There are some other theorems and stuff. I'll let you look at the notes on Piazza for those, but we'll focus mostly on the big picture here. So this is the last bit from Chapter 12. All right, CRG signing off. What I really mean to say here is scalars, not coefficients. The scalars come from F, and the vectors are just whatever the elements of K are. And when we talk about linear combinations of vectors in K, we're saying put together elements of K, scale them by elements of F, and add them up. And that's why addition is closed. That's why multiplication is closed, because everything that we're doing in K with scalars from F is just kind of a riff on the field axioms for K being a field itself.